Welcome to this demonstration of Adroitec Quality Sheet Generation tool. Let's start with something familiar. Do you also generate drawings like this with dimensions numbered with pen and later charting down all these dimensions into a table? Typically, in every organization, probably in yours as well, once the component is out from manufacturing, the quality inspection engineer has to inspect the component if it is complying with every dimension that is put there on the manufacturing drawing. For which he creates a drawing of this sort, which has got a lot of dimensions with tolerance, without tolerance, GD&Ts, etc. Where he has to go ahead and number each of the dimension and list that down into a table as well. This is where we could come in. We have Adroitec's Quality Sheet Generation tool. Let me take you to the software directly. I've taken a typical manufacturing drawing which has got different types of dimensions, normal dimensions, reference dimensions, dimensions with tolerance, without tolerance, notes, etc. So let us see how our tool can help you with this. First thing first, let's tell the software the basic preferences that you would want to adopt in this. Here we have multiple shapes for you to choose from. We have circle, hexagon and octagon as of now. You can set what is the shape you would want to prefer. I would go with the hexagon. And you got a confirmation. Yes, hexagon is set. And now coming to what would you want to do with open dimensions. We now have to choose the tolerance standard that has to be followed for dimensions that do not have or do not enforce any kind of tolerance. Typically open dimension. What is the standard to be followed? Let us choose that. So we have fine, medium, coarse and a very coarse. Right? I would go with medium. So yes, medium tolerance has been set. Right, now that we have set all our preferences as per our company's need or essential, now it is time to generate the QC. I can just go ahead in an instant. It says generate QC sheet. So software automatically takes over the drawing to start numbering all the dimensions. Right, Excel sheet saved successfully. Do you want to open the file? You see that? All the balloons. When I say open the file, it will also launch the file in a spreadsheet application that you have in your PC. You see that? The balloons that were created has got listed on the column 1 and the drawing's name. And if there are multiple sheets, you will have the sheet as the page 1, page 2, which is typically the sheet in which the drawing is present. Then the type of dimension that we are speaking about, is it a length or a diameter or a radius, angular dimension, whatever. And then the required dimension, the base dimension or the nominal dimension, and the unit along with its upper limit and the lower limit. For dimensions for which there were no tolerances, it has taken the tolerance from the tolerance standard that we have chosen. In this case, we chose medium, right? So that has been taken, leaving a place for a result as well. Now the inspection engineer can directly go ahead, enter the values that he has measured against any of the value that he has measured. So in this case, say let the value it has come to 114.5. Right, that's very obvious. It's not within the tolerance. You have it turning red. When it is within, it goes green. Okay. When it is within limits, it turns green, and when it is out of limits, it goes red, giving a visual feedback to the person who has entered. Right, and on the top, I think you would have already noticed we have some attributes already added, like part number, part name, anything, a lot number, vendor code, whatever, so that you don't have to deviate from the currently used file format or the inspection sheet format. Right? Probably it is part of your standards, being annexure to your job card or something, right? So it is a configurable thing. Now let us quickly go through this drawing as well. So you have balloons placed corresponding to every dimension, and you will see that they are also attached to it as the dimension moves. Because once the balloons are created, you may want to clean up, right? In case there are any need. So in that case, it is comfortably attached, so that when you move the dimension or modify it, it automatically gets attached. And also, even the balloons are moved. So in this case, if you see the GD&T has got numbered, which is overlapping with something, you can do that as well. So that way, it reduces a lot of time for you to go number each of the drawing and have it entered into a table. In just a click of a button, you have got all these done. I hope this makes sense to your organization as well in saving the time of a designer, so that the designer does design work and the quality person does quality related work, eliminating the clerical job. Typically, people say they get to save close to 90% of time spent when it compares to manual generation versus automated. I hope you will also be able to appreciate the benefit of this too. Thanks for watching the demonstration.